Okay, dear students. So today once again we are dealing with, or we are discussing about the equation of line in the vector form. As we discussed in the previous video, what was that? That the equation of line when it is passing through a particular point and it is parallel to the given vector, right? We have discussed already the vector form. What was that? Vector r is equals to a plus lambda times vector b, and we have made this equation as well. It is x minus x1 upon a equals to y minus y1 upon b equals to z minus z1 upon c. Now what are these x1, y1, z1? These are the coordinates of the point that will be given to us. What are these a, b, c? A, b, c are the direction ratios of the vector to which the line is parallel. Now if you people notice, I have put one more equation in the box where L, M, N are used. Now what are these L, M, N? We know very well. In our previous chapter we have discussed A, B, C are called the direction ratios, and what are L, M, N? L, M, N are called the direction cosines. And it is a very important result that we have, that the direction cosines can always replace the direction ratios. But the other way it is not true. Direction ratios cannot replace the direction cosines, but direction cosines L, M, N can always replace the direction ratios. So if the direction cosines L, M, N are given instead of direction ratios, I can always have the equation in the same form. Only in place of A, B, C, what we will get? We will get L, M and N. The equation will remain same. Okay. So let's work on some examples to understand how the equations will work, how to apply the formulas to get the equation. So let's move to the next slide and see a particular example. I have taken the solution thoroughly in front of you, but let us understand step by step how it is coming. The question is, we have to find the vector as well as Cartesian equation of the line which is passing through the point. Now the point is given to us. What are the coordinates of point? The coordinates of point are 5, 2, minus 4. That means x1, y1, z1 point is 5, 2, minus 4. Okay. And the line is parallel to the vector. So the line which is parallel to the vector, this given vector, what is this vector? It is the vector b to which the line is parallel, right? Now we know if the point is given, I can always write down the corresponding vector in the component form. So what will be the vector in the component form? Vector A can be written as, then it will be x1 I cap. What is x1? 5 I cap plus y1 j cap, that is 2 j cap minus 4 k cap. So what is this vector A? It is the position vector of the point through which line is passing. So now the point we have converted into the vector. Okay. The parallel vector is already given to us. So let it be vector B. Vector A is there, vector B is there, and we know vector R is always the vector which is having the variables. It will be xi cap plus yj cap plus zk cap. Now nothing to do, we will be just putting the vector A and vector B in our formula. What is the formula? That vector R is equals to vector A plus lambda times vector B. Vector A we have written, we are keeping the vector A as such, plus lambda times vector B which is given to us, we are putting it there, and the equation is done, right? The only thing is, now what is vector R? That I will write. Vector R, as we said, it is the arbitrary points corresponding position vector. So vector R will be written as xi plus yj plus zk cap is equals to A vector we will keep as such, plus lambda times B vector also we will keep as such. Now to make the equation in a simple form, what we will do, because if you notice in the right hand side there are two terms with I cap, two terms with j cap, two terms with k cap, we will club them, right? So it is 5 I cap plus lambda times 3 I cap. So what I will do, I will just put the components of I cap in the bracket. It will be 5 plus 3 times lambda into I cap. Then I will club the components of j cap and the components of k cap in one bracket, and the question is over. So what we are getting here, this is the vector equation of the line. Okay. And now how to convert it into the Cartesian equation? Very easy. The point is given to us 5, 2 minus 4, it is x1, y1, z1. The vector is given 3i plus 2j minus 8k. So the coefficients of I, j, k in the given vector, what are they? They are the values of A, B, C, that means the direction ratios. So if I put these values in the Cartesian form equation, what we are getting? We will get the Cartesian equation. So let's move to the next slide and see Cartesian equation of the line is given. Now the question has gone to the other form. The Cartesian equation is given, we have to find the vector equation. Sometimes the question comes this way also, you are given the equation in one form, you have to find the equation in the other form, as we are having the question here. So what is this Cartesian equation? X minus x1 upon a equals to y minus y1 upon b, z minus z1 upon c. As we know, the denominators are the direction ratios a, b, c. So what are the values of a, b, c? 2, 4 and 6, 2. And x minus x1, if I compare the equation with the given equation, in the given equation we have x plus 3. That means the value of x1 will be minus 3. And y minus y1, it is y minus 5. So the value of y1 will be 5. And z minus z1, it is z plus 6. So the value of z1 will be minus 6. I got the point x1, y1, z1, minus 3, 5, minus 6. I have the direction ratios 2, 4, 2. I can easily write down the equation, that is the vector form, using the formula vector r is equals to vector a plus lambda times vector b. That I hope you people will work on it, okay, because we have just simplified, and if I put it back in the vector form of the line, what we will get? We will get the required equation of the line. That I expect from you people to complete that equation, because you have to just put it in the equation and you are getting the required equation of line. So that's it for today, because we have completed one particular topic, that the equation of the line when it is passing through one point, and the direction of the line is given in the form of vector b. Thank you so much, students.